have magnitude and direction, but not super helpful if you have to draw them all the time. It's very annoying to have to do this. So one of the keys to understanding vectors is that we can move them all over the place. And where is the most convenient place for us to set the tail of the vector? At the origin, yeah. If you set the tail at the origin, you can describe every vector with where the head is. So what we're going to do is to describe a vector on a plane, on a Cartesian plane, we're going to use a point x, y. But just a quick reminder, what that means is that's where the head of the vector is, assuming the tail is where? 0, 0. Yep. And it could be 0, 0, 0 if it's in 3D, which we'll get to 3D. Now, to describe this vector, we can describe it in terms of what we call unit vectors, vectors of length 1. And we'll use I and j. It's a little confusing because complex numbers use I as well, but I is in the x direction. So each one of these in the x direction is a unit vector I. How many i's do you see for this one? 5 of them. So we would say there are 5 of the I vectors plus j vectors is going to go up in the vertical. 1, 2, 3 of the j's. And so that's going to be 3j. So this vector A here can be written in a position vector form as 5i plus 3j. That's what we call position vector form. The one I like that's a little better is you can describe vector I in what we call a column vector form. We'll put 2 parentheses and the number of I unit vectors and the number of j unit vectors go here. And can you kind of see how this is much more efficient, quicker to do? So position vector, column vector, to describe a vector whose tail is where? There you go. Tail is at the origin. That's important. And so we can prove how these are connected by taking this vector A, and we'll take this as the column vector form. Here, and we're going to break it into x0, 0y. So this is going to be my x of the I unit vectors and y of the j unit vectors. One more time. So let's say this is 5, 3. 5, 3. Well, there's 5 of these I vectors, which we saw, and 3 of the j vectors, which we saw, which, when you add these up, it's going to be x of the i's and y of the j's. And this is my position vector. There you go. Those are the 2 forms that we're going to use. And why is that great? Well, you're going to see. What would it take to get this into 3D? Well, you've got this x, I, y, j. I bet you could go zi and get the 3rd dimension. So this is going to be xi plus yj plus zk. These little half arrows mean that they're vectors. You okay with that? You know me. Go into the next dimension any chance we get. We can do 4D if you want. So how does this make life easier for you? That's all that matters, right? Well, everything is easier now because once we place these tails at the origin, now what you can do is you can describe these vectors with a position vector. So A is no longer this arrow in space. With the tail at the origin, A is 1, 2, 3, 4 of the i's and 1, 2, 3 of the j's. Okay, let's get this one out of here. And let's go with the b now. Tell me about vector b. Vector b is going to be how many i's? Careful. 1, 2, 3, 4, 5. Negative 5 of the i's and how many of the j's? 5 of the j's. No k's because we're not in 3D. So now what we can do is we can add these just like we did before. I'm going to run out of space, so I'm going to start down here. I'm going to go A plus B. So here's A, and here's B. Now, if you look at my answer, it looks like to go from the tail of the first to the head of the last, we're going back 1, and we're going up 1, 2, 3, 4, 5, 8. You okay with that? But watch this. Let's do this with vector column vectors. You're going to have 4, 3, and negative 5, 5. Okay? Instead of drawing these and doing all this adding and junk, look what happens when we add across the top. 4 minus 5 is negative 1. 3 plus 5 is 8. Again, math easy, concept hard. How about for subtraction? Well, what happens with subtraction is we're going to reverse A minus B. So we're going to start up here. Let's try this one. A minus B. So this one's going to go down here. There's A, and here's minus B. Minus B is this one. So when we draw that final resultant, we go from the tail of the first to the head of the last. And so notice that we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 in the i's and 1, 2 down in the j's. There's no way this is going to work. 4, 3 minus negative 5, 5. There's no way that this is going to work, is it? Totally works. 4 minus negative 5 is going to be 9. 3 minus 5 is negative 2. All is happy, all is well. Now, can you even do multiples like 2a minus half b? Well, I'm not going to draw it. I'm just going to go right for the jugular here. 4, 3 times 2. And then I'm going to go 1 half times negative 5, 5. Got a little fraction action here. This is going to be 8. 8 plus 5 halves. And this is going to be 6 minus 5 halves. So this is going to be 16 halves plus 5 is 21 halves. And 12 halves minus 5 is 7 halves. What do you think? That's it. That's it for today. That's all I have for new stuff. And so go down to the homework, day 3, and we're going to use some vectors that are already made. Here's a vector A. Looks like this. 1i, 7j, negative 1k. Then I have a B, which is 4i, 7j, 5k. See if you can find 3b and 2a minus b.